For me, it's an absolute honor to be here to kick off this event and kick off your school year. And it's really exciting also because this is especially exciting because it's an exciting time for the industry. And just this past month, President Biden signed the CHIPS and Science Act, which provides $52.7 billion to the American semiconductor and research for American semiconductor research. And that's really underlines unequivocally how important this industry is for the future. And it's really an investment into every one of your careers. So let me back up a little bit first and introduce myself. I am Renu Mehra, and I'm in Synopsys. I have been in this company for 25 years and in various different roles. I'm currently the VP of Engineering, heading the RTL synthesis team. And before Synopsys, I did my bachelor's in electrical engineering from the Indian Institute of Technology in Kanpur. And I did my PhD and master's from the University of California in Berkeley. And my passion was in low power design. And I also want to give you a little bit about what Synopsys does. So in Synopsys, we create the software that helps design chips and verify these chips and make the semiconductor industry even possible, and really powers the Moore's law as it's been going for the last so many 3-4 decades, I believe. And when I started my career at Synopsys, we were designing with 120 nanometers, and now we are looking at 3 nanometers, and even looking some of the chips we are designing are even starting to look at below that. So it's been very exciting. So what I wanted to do was, in our culture, which is obsessed with talent and ability, we forget sometimes about inspiration. And what we want to do in today's panel is to take inspiration from all the different careers that are presented here. And we will explore stories of 4 different amazing paths and different careers in the semiconductor field. And through these stories, we look not only at the exciting technologies that our panelists have enabled, but we also see how many different ways you can have a career in the semiconductor industry. Whether you want to have a marketing career, or you want to be a technology architect, or you want to have a leadership role in different ways, there are lots of exciting opportunities out there. So let me introduce my panelists. We'll start with Norma. So Norma is the senior director of global field marketing at National Instruments. She graduated with an electrical engineering degree here at UT Austin. And she has worked multiple stints at Applied Research Labs, IBM during college. And then she joined NI when the company was still very small. And in her 20+ years at the company, she held lots of positions in applications engineering, product management, talent management, research, and global marketing. And today she heads the NI teams developing, she heads the NI team that is developing global campaigns and strategy, activating sales and channels with field marketing worldwide, and enabling NI's partners to co-market in support of shared customers. So Norma, I would like to have, my first question to you is, why don't you introduce your career to the audience, and also talk about one word that describes you and describes your pathway that has really energized your pathway to success.
Sure. Okay. Thanks, Renu. Can everybody hear me? We're using these lavalier mics. So I also joined the dark side by not staying in design. I wound up, coming out of school with my EE degree, totally expecting to work for a couple of years at this company that was headquartered in Austin that I had never heard of. And then I was going to go back to school and get my master's degree after I made some money, right? So like that was my plan. And did not happen because when I joined I got exposed, similar to Kim, to all of the different career opportunities that are available to someone with an engineering degree. And it just kept growing and growing and growing so fast. I changed my job every year. And when I got out of college, what I realized was that I just did not want to get bored. And the one word I think really is curiosity for me. So similar to Kim, I am fascinated by random trivia. I would totally have talked to the cattle farmer. And so I just discovered that what I loved about NI was how, semiconductors kind of power the world of smart anything. And when I was product manager, I got to go to see the Ford shaker tables, right, out in Detroit. I could go and check out at the time, I know this is like our first Mars Pathfinder, like I know I'm really old, but it was like, oh, Jet Propulsion Labs, and checking out like what we were doing with the Pathfinder, being able to see like this guy who, of course, as a product manager, you get all sorts of questions around like why your products don't work from your customers, for something. And it's kind of like, okay, this discussion, but then you get to see that customer do something amazing and what they love, right? So we're talking about our products. And then I ask them about what they do. And this guy telling me, I help deaf people hear, with these like new oral implants. And he's like, I can't, the amazing, kind of light up on somebody's face. And, that is powered by semiconductors, like your cars, your space, all of these things. And so when I, started working towards like being able to be a marketer, which sounded crazy, what happened was I really enjoyed helping people understand how technology changes the world and how our products and solutions could help make that impact to do good in society, to create, clean water and safe infrastructure and all those things. And so that's how I got into marketing and all sorts of marketing, corporate marketing, global field, partner marketing, global insights. I went part-time for 7 years of my life because I had my kid and decided I didn't want to travel 20 to 30% of my life before that, though. That was super fun. Kim and I were just talking about Tokyo and getting to go, to Germany. I think India was like my favorite because it was so different than every other city, that I had landed in, and would get in the cab and go to my hotel. And that wasn't like that in India. So that was so cool. So those are some things, like just being curious just started pulling me into all of these different directions. And like Kim said, once you develop your personal kind of reputation of not what you do, but what you can do, I think that just continues to open doors for everybody. And I've not gotten bored in my 27. When I do get bored, though, I'm totally coming back here. I'm learning something new.
Thank you, Norma. That is so exciting. So you can see that even if you go to the dark side, it can be extremely exciting, even after your degree in semiconductors. So our next speaker is Gozde. Gozde Fidan is the director of RF design validation at Silicon Labs, and she manages a team of RF engineers who are focused on design validation of IoT products. She joined Silicon Labs in 2006 as an application engineer in the broadcast audio group. And then she had several different roles she's going to talk to us about. And she created and led the timing systems engineering group, working on the company's precision timing products that included wireless clocks and oscillators. And she's previously has worked in other companies, Intersil, which is now Renesas, Agilent Technologies, which is now Keysight, and National Instruments. She earned her BS degree from the Middle East Technical University in Turkey and her MS EE from Penn State in 2000. So Gozde, tell us about your favorite word that has powered your career.
All right, thank you so much. So I would say, and it would emphasize what we've heard today. I think adaptable is what I would emphasize here. So I would even start before getting an EE degree. I wasn't the kid who was opening up radios, TVs, or gadgets, and really your stereotypical electrical engineer to be. But I was really into math and science, and some of that is kind of ingrained in your brain by your parents in Turkey. So by just being good at those types of classes, I ended up in electrical engineering. But once I got there, I really figured out that I found my people, if you will, folks that are really curious about things, learning, and then I got into tinkering with stuff. So out of college, my major was really high frequency design, telecommunications. I worked in military electronics. And I came here to do my master's degree, and I was really kind of set on, graduating from here. I'm going to work in, satellites and, remote sensing and stuff. Then somebody told me that, hey, wait a minute, you're not a US citizen. You can't work in that industry. So I'm like, oh, okay. So I had to pivot. That's how I got my first job at Agilent Technologies. They were doing high frequency test and measurement equipment. So I worked there for about 5 years, really learned a lot from some of the RF experts in the field. Then again, for family reasons, I moved to Austin and worked at NI, still doing test and measurement. But just again, by pure coincidence, one of my coworkers ended up in this company called Silicon Labs, and they were super excited about it. So they recruited me into Silicon Labs. Until joining Silicon Labs, I didn't, deal with semiconductors other than, using them on my, PCBs that we were designing. And, I was hyper focused on, I have to always be a microcircuit designer or a PCB designer. And then, once I got into applications engineering, I found out that there's a whole new world out there that I didn't even know about, which still includes, you designing stuff. But you can also now test something's performance, talk to different customers, learn about all sorts of different applications people are using your chips in. On a daily basis, you go from one type of activity to the other. To some of you, that's great if you don't like being bored and being kind of pigeonholed to doing one thing. To some others, it might be horrible because you're like, I don't want to keep multitasking on stuff. So it's kind of all depends on who you want to be. And then, throughout that, I became an engineering manager again, had to pivot again. Up until that point, I was always thinking that, I have to be on the technical track and, management is a bad word. So, but once I figured out it just means it's solving different types of problems now, again, growing teams, getting people to, align on a specific goal. I got excited. I really got into it actually. Then, I had to pivot and get into software because up until that point, I was only dealing with hardware. Had to, take on software groups, try to speak different lingo between hardware guys and software guys, bridge the gap between them. And now, I'm back to doing some of the RF type of work that I really love, but it still involves talking to different people in different parts of the world, getting into different applications, test cases. So I would say that, again, I think Allison and Kim also said this, have an open mind. Don't be obsessed about doing one thing forever, right? Try different things. You never know what your real passion is until you kind of sample some of these things out there.
Thank you, Gose. So be adaptable. What an inspiring thought. Always, that's what we learned in the last 2 years as the world adapted to just being shut down and being isolated. I think human beings really have the capacity to do that. And that's a very, very important skill. Our next speaker is Derek. Derek is professor here in the Electrical Engineering and Computer Science Department in University of Texas. But in addition to that, he's also partner architect at Microsoft, and he's responsible for the future infrastructure offload system architecture. And he's the co-founder of the Microsoft Azure SmartNIC effort. and he led the Bing FPGA team to first deployment of Bing ranking on FPGAs. And before that, Dr. Chu was system architect at Avicii Systems, a manufacturer of terabit core routers. And Dr. Chu received his PhD, his master's and bachelor's degrees in electrical engineering and computer science from MIT. And I'm really thankful to both our male speakers here, because they are our super allies. It's really important, as we listened to the previous speakers, to kind of have diverse thought, to have different, even if you are a woman looking for advice, you will sometimes find advice in all kinds of different sources. And so I'm really happy to have both Derek and Gary here as the allies of the women community. So Derek, what is your favorite word that has powered your career?
I think for me, it's contrarian. I like to do things different than other people like to do them. So when I was a kid, up until 5th grade, I wanted to be a fighter pilot. I like going fast, right? Then my eyes went bad. I got glasses, and my dad, from a military family, said, "You're not going to be able to fight. You're not going to be able to be a pilot. You can be a navigator." I'm like, "What's a navigator?" And they sit in the back and they direct. I'm like, "That's it. I'm not going to be a pilot anymore." So I switched to I wanted to be a professor. My dad was a professor. My grandfather's a professor. My 2 uncles are professors. We have many other professors in the family. So starting in 5th grade, I knew I wanted to be a professor. So I went to school. I knew I needed to get a PhD because they don't let non-PhDs become professors. I went and got a PhD, and I spent 10 years in grad school. So for those of you who know how long grad school is supposed to take, it's not supposed to take 10 years. I had 2 master's theses. I had 3 PhD theses. A lot of complications there because projects got canceled. I was depending on a Motorola chip, in fact, that didn't finally come out. So I had to switch my PhD and so on. So 10 years out, and I knew I wanted to be a professor, but I'd spent 10 years trying to build a big parallel computer. I wanted to have enough resources to actually get the computer done. I went and visited, while I was a PhD student, we visited IBM, Sun. They were all building these machines, and we were ahead of them. But it was me and 3 other grad students building the machine. And these guys had 50, 100 people working on these projects, which were actually much bigger than 100 in some cases. So I wanted to go to industry for a while to see how to actually build something. So I joined a startup company called Avicii Systems. When I joined, it was 200 people. We grew to 400 people. Our routers became the backbone for AT&T's network. Learned a lot there. I learned a tremendous amount there. But then I knew I wanted to be a professor. So 5 years in, it turns out if you want to be an assistant professor, they don't pay attention to you if you have gotten your PhD for more. You've been more than 5 years out from your PhD. Right? Otherwise, they have to start considering you for a non-assistant professor position. And it turns out, as we know in academia, it's not so easy to get non-assistant professor positions. So I applied. I was lucky enough to get a position at UT. I was working on high-performance simulators. What we tried to do is we tried to build cycle-accurate computer system simulators that would run at 100 megahertz. This is when Intel is running their cycle-accurate simulators are really in the 1 to 1,000 hertz. So 100 million is very, very fast. And we did that using FPGAs to accelerate that, right? So one thing I want to point out is I used FPGAs in my research at UT. I used FPGAs to build these high-end core routers. We were building core routers that were competitive with anything on the market. When we started, we were building 10 terabit routers when Cisco was building 80 gigabit routers. So we're about an order of magnitude faster than Cisco was. And we used FPGAs extensively in our product. I also used FPGAs in my PhD, which is actually a NIC. Built out of FPGAs, a processor, and some ASIC component. So I was at UT. Microsoft came and recruited me because they had an FPGA program that they wanted to start. This was the Bing program to accelerate ranking with FPGAs. I went to lead the team at Bing to go to production. But one of the things that my boss at Bing told me is you have to get FPGAs spread throughout Microsoft, because if we don't, we will not be able to use FPGAs in the future. So I went and spent a lot of time with Azure. I wound up convincing them to use FPGAs to accelerate their software-defined networking. And so I've been working on that project ever since. I've been at Microsoft, and it's been a great project. We're working on our 6th generation of it. We've deployed many FPGAs in the data center. So At some point, I wanted to come back to academia. I applied and they made me an offer. So I'm back here as a professor starting this semester. Some of you are in my parallel computer architecture class. I really enjoy being back, but I am still working with Microsoft, obviously, with that much less time. So to me, the reason why I say contrarian is for those of you who know about FPGAs, the conventional wisdom is you don't use an FPGA if your volume is bigger than 10,000. I've deployed millions of FPGAs in Microsoft's data centers. In fact, every Azure data center server ships with an FPGA. There's a few exceptions, like when we deploy a Cray supercomputer, it turns out they don't have space for an FPGA in it. So in those cases, we don't. But fundamentally, almost every Azure server deploys with an FPGA. The fact that we're using FPGAs when the conventional wisdom says you should not do that really is the foundation of my career, is really looking for alternative solutions, which I consider to be better, that, to be able to go and solve a problem that was difficult to solve in any other way before.
Be contrarian. If you believe in what you're doing, there is nothing, you don't need to be shaken by the conventional wisdom. And really FPGAs have really powered the AI training and AI revolution. So they have played a huge role. And I think great. You had the faith in that and you pursued your passion. Our next speaker is Gary Kotzer. He's the Vice President and CTO of the Storage Division in Marvell Storage Products Group. Gary has over 25 years experience in the computer industry and was previously in Dell EMC prior to joining Marvell in 2020. He actually joined Marvell in the middle of COVID and did not even, he told me he did not even see his co-workers for almost more than a year after joining the company. That's really adaptable. Gary's team is responsible for delivering product architecture, the technology vision, and the strategy for storage and memory products. And he has initiated and been involved in a number of industry standards and being an active member on their boards. And he has been granted 69 patents. He holds a bachelor's degree in electrical engineering from Texas A&M, the rival university here, and a master's degree in electrical engineering from the University of Houston. So we'd like to hear from Gary. What is your word that has powered your career?
You outed me right off the bat, didn't you? Going to Texas A&M. The word that would define me is creativity. But in addition to that, you also have to have the curiosity that was mentioned before, as well as the drive. Derek used contrarian, but those are attributes that have really helped me throughout my career. Now, I was one of those kids that took things apart. The problem was that frustrated my sisters and brothers was that I didn't always get them back together and work right, but I tried. So there was always this curiosity factor that I think will serve you well when you go into the engineering field, whether that be in the R&D or whether the engineering execution side of it. When I look at my career, I first started in the semiconductor industry doing ASIC design. And that has served me well as a vehicle. And let me explain is that after doing ASICs for a number of years, I decided that I wanted to go into systems. So systems are, the computers, the networking, and the storage side of it. So after doing ASICs for a while, I went first into computer architecture and did that for a while, but I was still doing chip design. Next, I wanted to try networking, also doing chip design in that field. And then last, I went into storage. So it gave me a good all-around background from the different key architectures that are used inside of data centers today, even though there are some other derivatives that have spun off from that. So whenever I look at the job I have today, I was hired because of that diverse background. If I had been just focused on one aspect, I don't think it would have been something that would have been applicable to my current role today as CTO. So, I would advise you, just as, Kim mentioned earlier, is that to be open to opportunities. Whenever you see, opportunities, consider them. And also too, that if you're not really enjoying that particular job at the time, look for other avenues. So I think all in all, you have to be open to opportunities. You have to be curious, and look for a company and a group that will appreciate your value. I think that's very important so that you will enjoy your overall job itself.
Thank you, Gary. So I would like to pivot a little from our technology discussion and career discussion into work-life balance, which is one of the things that I'm sure that people here, whether women or men, we all have to think about the logistics a little bit, and something maybe when we're students, we don't fully think about those challenges. So maybe if we can hear from you, what were the challenges you faced, and what are the little tips you want to give to our audience on how to navigate the work-life balances? So Norma, do you want to go first?
Oh, sure. Okay. So to me, work-life balance is very individual. I mean, I had a boss one time who I was worried about some of the guys working so late. He's like, well, don't stop them. They wanna, they're interested. They want to do that. But when I wanted to do something different, like I said, I actually went part-time, and I thought I was going to do it for a couple of years, and it actually turned into like 7. I decided that was the trade-off that I wanted to make so that I could spend more time with my kid growing up instead of traveling all over the place. And I think it's just a matter of like your choices. You decide what you think is the right thing for you, and it doesn't matter what other people think, your parents, your colleagues. My mom, who was like, why are you going part-time? I was like, it's fine. Like this is what I want to do. And then I entered back into the workforce full-time, and just was so excited about work every day. And so I think it's just a matter of like, you decide what is important to you. And it, isn't always like even like, 30% of my time will be spent on this and 30% of my time will be spent on that. It's going to be a different flow as you kind of go through life, right? And as Kim talked about the journey, you're enjoying your journey and you're deciding like at any given time, like what is best for you. And there is no right or wrong choice. It's just your decisions. And, it's not all going to be like perfect. Like, sometimes, it's not going to work out the way you want, but that's okay. To Carrie's point, like find something else. There are so many opportunities, just change. So I think that's kind of how I approached it.
Gary, do you want to also put in a few words on this topic?
I thought we were going to go. Anyway. Sure. I'm going to borrow a quote, and I hope I don't butcher it up too much, but this was from Brian Dyson, who gave a commencement. This was later borrowed by the CEO of Google. But basically is that, you need to treat life as a game where you're trying to juggle these 5 balls. And the 5 balls are work, your health, family, friends, and your spirit. And when you're trying to juggle these balls, you're going to have to drop something. But one of those balls, that of work, is a rubber ball. And so it's the only one out of the 5 that can bounce back if you drop it. So all the other ones, you need to do your best to, make sure that you keep, your friends, your family, and your own spirit, and as well as very important is your health. So, overall, you have to look at work is important, but you need to balance everything else along with it. Now, if you were to, ask me one of the things that's important about work-life balance is, I believe it was Kim, I'm not sure if it was Allison or Kim, I apologize, but you talked about your partner. And whoever you choose in life to be your life partner, make sure they're really a partner. Make sure that they're looking out, for your own ambitions, and your personal goals, because having that support system is so key. Now, there are other things I could talk about work-life balance, but I'll just mention that one as kind of the key ones.
Thank you, Gary. I think, yeah, very, very important. The work ball is the rubber ball. If you decide to take half time, go half time to take care of your family, you can come back. That's awesome. I would like to find, I have a question on why semiconductors? What excites you most about this industry? And why do you think that a student in 2022 should, who's at the cusp of starting their career, should choose this industry? Derek, do you want to take that question?
Sure. Semiconductors are very unique in terms of all engineering areas. I mean, if you look at the progress in semiconductors from the start to now, I just heard somewhere that, we make more transistors per year than there are grains of rice and wheat grown every year. I mean, if you think about the number of transistors we're generating, it's huge, and the opportunities that those transistors enable are huge as well. I mean, semiconductors are becoming harder and harder. Before every 18 months to 2 years, you'd have a next generation. These days, it's really gotten a lot longer than that. But what that means is there are harder problems to solve in the semiconductor world. It becomes harder. But on top of that, when we're looking at the size, the size of chips that we can build today, the opportunities that you have to, make those transistors and structure them in a way to actually be more useful, to be more effective, to attack new problems is much bigger than it's ever been before. I mean, I remember my PhD, the number of transistors I had to work with I had to deal with the fact that it was very limiting. Today, you're almost not limited by the transistors. It's really, you're limited more by what you can imagine. So I think it's an incredible playground to do really innovative and important work.
Gosde, do you also want to chip in this topic?
Yeah, I think, if we learned anything during the chip shortage is that everything has a chip in it, right? Which means there's, endless possibilities of, these different applications that the semiconductors go into. So I think that's the unique part that, attracts me to that field is that I can never get bored doing one type of thing, right? One day I'm going to see, our chips in, a medical device. The next day it's going to be on a wearable. The next day it's going to be on a, camera, So the possibilities are endless, which means that there will always be, investment in this field, and, there will always be interesting projects to work on. Also, you can point your friends and family to things where your chips are in. I couldn't do that with network analyzers. It was really hard to do that.
That's awesome. Yeah, what we are working on is really touching everybody's lives on a day-to-day basis. So that's in my view. I also had a very hard time explaining to my kids what was semiconductors. But that was like 10 years ago. And I think now it's becoming more and more easy to tell people what is the impact we are having on people's everyday lives. As we build these semiconductors, they power almost everything we do. I have another question on how are we doing on time? Okay. 1:10. So should we just have one more question in? Yeah. I wanted to ask one more question before we end is, what is the role that mentors, both formal and informal, have played in your life? And what is your advice to find the best mentoring opportunities and make the best out of the mentoring opportunities? Norma, do you want to start with that?
Sure. So I think Kim talked about sponsorships, and I absolutely believe that advocates are the people that you can cultivate to help move your careers along, and that mentoring is, people. I think there's actually a book who's like, "Can you be my mentor?" And it's like, no. It's not about that. It's about learning. What do you want to learn about? And finding like who is really good at that within, your network and your folks, and approaching that person for that kind of mentorship. And so you'll have many mentors. It's not like you have one mentor. You'll have mentors that maybe help you with your well-being. You know, you might have mentors that help you with the actual job itself, mentors that help you with career, personal growth and development of leadership capabilities, communications capabilities. You have a board of directors, right, for your own personal life of all of these different balls that you're juggling. And so that's, to me, is how mentoring helps you. And then that advocacy and sponsorship is what really helps move your career forward, because you're not in every conversation. And those people that are influencing, when, you know, people are around the table trying to figure out who's great talent for that next opportunity, your name needs to come up if that's the right opportunity for you. So
Derek, do you also want to give some advice?
I think mentors, yeah, just following on what Norma said, mentors I've seen cases where we co-mentor, right? Someone may have more experience at Microsoft and, can provide a roadmap to how you can get your job done, while the other person may have, a particular area of technical strength that, the other person might want to understand better. So I find that's critically important, but really mentors and sponsors from, kind of different areas can really help. And I've been really helped by mentors, both in terms of academia and my career at Microsoft. So.
Thank you so much. With that, I think since we are really out of time, over time, thank you very much for everybody who's joined us. And thank you to the panelists for your inspiring stories. And I do feel that we are at the cusp of something great in the semiconductor industry. And you have a huge amount of choices. Starting out with this industry definitely cannot go wrong. Thank you very much. Let's give a hand to all our panelists.
All right, let me just close out the session quickly then. Just briefly, I'm Andreas Gerstlauer, professor here in ECE and associate chair for academic affairs. So I wanted to first and foremost, obviously, thank our speakers and panelists again, right, for the insightful comments and career advice. I hope it was useful for everybody here. So let's thank them again, right? I also thank everybody for attending the session, right? And I please welcome you to join us for the networking reception outside. I hear there's lunch available, right? There's booth by companies. I've seen gifts floating around literally. So please join us for the reception. And I think all the speakers will also be available, right, for questions if you have any. Also, thank you, everybody, and see you out there.